Hello again. We're about halfway through our unit on quadrilaterals. In the last two lessons, we were talking about parallelograms. Today, we're going to talk about a specific kind of parallelogram called the rectangle. You've probably heard of it before. But let me show you some cool things about how rectangles work. Here we go. A rectangle is a parallelogram with four right angles. And because it's a parallelogram, it has all the qualities of a parallelogram, like opposite sides are parallel, opposite angles are congruent, opposite sides are congruent, consecutive angles are supplementary, and the diagonals bisect each other. We get to add something to this list now because it's a rectangle, and that is that the diagonals are congruent. So with that in mind, let's try a couple problems. If AC equals 2x plus 13 and DB equals 4x minus 1, we need to find DB. Now remember, the diagonals are congruent. So we can say that 2x plus 13 equals 4x minus 1, and we can solve for x. Now, x isn't what they asked for. They asked for the measure of DB. So we're going to take that x and plug it back into the equation for DB. 4 times 7 minus 1. And we know that DB is 27. What if DE equals 6x minus 7 and AE equals 4x plus 9? Well, the diagonals are congruent. They also bisect each other. Putting those two thoughts together, we know that DE and AE equal each other. So we can solve for x. Again, it didn't want us just to solve for x. This time, it wants us to find DB. Let's start by finding DE. So 6 times x minus 7. We found that DE is 41. Now we just have to double that to find DB, and we know that DB is 82. Let's try working with some angles. It says if the measure of DAC is 2x plus 4 and the measure of BAC is 3x plus 1, find the measure of BAC. What we know is that rectangles have four right angles. So DAC together with BAC is a right angle. Another way to say that is that 2x plus 4 plus 3x plus 1 equals 90. And we can solve for x. But again, they didn't just want us to solve for x, they wanted the measure of BAC. So we need to plug x back into BAC to find its measure. 3 times 17 plus 1, and we know the measure of BAC is 52. Okay, now I've got a challenge for you. We're going to graph the quadrilateral with these given vertices, which I'll show you in a second. We're going to determine whether the figure is a rectangle, and we're going to justify our answer using the indicated formula. Let me show you what I mean. Here are some vertices. We're going to graph it, make sure it's a rectangle using the slope formula. So first we graph it. Here are our vertices. And if we connect the dots, we get a quadrilateral. The question is it a rectangle? Well, how would we know? We know that rectangles have four right angles. And we know that the slopes of the sides, therefore, must be perpendicular. Now, a quick note. Perpendicular slopes are negative reciprocals of each other. A over B and negative B over A are perpendicular slopes. So we'll use that information to determine whether or not our quadrilateral is a rectangle. Let's just take two of the sides, and we'll find the slopes for each of those. First, we'll find the slope of PQ. So we'll take y minus y, 2 minus negative 2, divided by x minus x, negative 4 minus negative 3, which gives us 4 over negative 1, which equals negative 4. Now we'll find the slope of QR. So 4 minus 2, divided by 2 minus negative 4 gives us 2 over 6, which reduces to 1 over 3. Are these two negative reciprocals of each other? They're not. So the slopes are not perpendicular. Therefore, PQRS is not a rectangle. So that's a bit about rectangles. There's still parallelograms, but we've added another layer of information. So they've got 4 right angles, and we know that the diagonals are congruent. And so with those special characteristics comes some more ways of solving some problems. Thanks for being here.